Chapter 4. The Nature of Capital. Given what capital is, what is its nature? How do aspects of the physical world, including ourselves, influence and determine capital? I will argue that the capital of property is the quantification of its functionality used by other forms of property. The most recent market price paid of property is simply the way we can measure this used functionality. The functionality of property is the range of attributes and operations that property has. Communication provided by a phone, transportation provided by a car, energy provided by fuel, nutrition provided by food, shelter provided by a house, entertainment provided by television, access to information provided by internet service, earnings provided by a business, labor provided by a person. It is these functions that are used by all forms of property, including ourselves. As property owners transacting in the market, we choose among those goods and services that best provide those functions we use. The market price of property, then, is a negotiation between the buyers who are able to pay for the goods and services with desired functionality and the sellers who own and provide such goods and services. What determines these functions of property? The functions of property derive from its nature. We can understand nature through theories we discover logically and experimentally. These theories of nature predict what will happen for certain aspects of nature. They relate aspects of nature to one another and predict how those aspects evolve over time. Here are a few examples. 1. The acceleration of an object as determined by its mass and forces exerted in accordance to Newton's laws of motion. Newton's laws state that the sum of forces exerted on an object equals its mass times its acceleration, and that the force an object exerts on another object is equal and opposite to the force it receives from that object. So in the case of a car that weighs 1,000 kilograms, has an engine, drivetrain, and tires that exert a constant force of 10,000 newtons parallel to the road, and has an aerodynamic design with a constant drag force of 1,000 newtons, it will accelerate at 9 meters per second squared, approximately 0 to 60 miles per hour, in 3 seconds. 2. The change in position by an object, the distance it travels over time, as determined by its acceleration. Acceleration is defined as the rate of change of velocity with respect to time, and velocity is defined as the rate of change of position with respect to time. Assuming acceleration is constant, a derivation from calculus, integrating acceleration with respect to time twice, will tell us that the change in position is equal to the initial velocity times time plus the acceleration times time squared divided by 2. From the previous example, for the car at rest and a constant acceleration over time, it will travel 40.5 meters in 3 seconds, approximately 133 feet. 3. The power consumed by a light bulb as determined by its electrical resistance and voltage applied. Ohm's law states that voltage equals electrical current times electrical resistance, V equals IR. A derivation of Coulomb's law states that power equals electrical current times voltage, P equals IV. Combining these, we derive that the power consumed equals the voltage squared divided by the resistance, P equals V squared by R. 4. A bland dish tastes better with a pinch of salt. 5. The sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. 6. 2 and 2 make 4. 7. Unfinished or untreated wood will rot and decay quicker. 8. We need food with proper nutrition to survive. To the extent we have knowledge of these theories of nature, combined with control over nature, we can organize property to create those functions that we and the market most desire. Let's consider a set of examples. Microchip. A microchip is a unique combination of silicon, transistors, logic gates, adders, registers, geometry, and circuitry. Only in its provided organization do all the components work in harmony to produce a set of functions like specific voltage signals, memory storage, processing speed, low heat output, and small form factor. If just some of the physical logic gates or transistors are contaminated, say due to impure processing conditions, the entire microchip may be rendered non-responsive. Smartphone. A smartphone is a unique combination of microchips, battery, display, casing, wiring, programming, and many other components. Only in its provided organization do all the components work in harmony to produce a set of functions valued by the user, such as talk and text, access to the internet, and long battery life. If just some of the components are organized in a slightly different manner, perhaps a misplaced or damaged wire or transistor, the smartphone could malfunction, and its functionality would severely diminish. Car. A car is a unique combination of chassis, engine, transmission, tires, electronics, alternator, radiator, airbag, braking system, suspension, interior and exterior body, such that only in its specific organization does it provide the comfort, acceleration, speed, safety, reliability, fuel mileage, and space desired by the user. If just one of the components of the car breaks down, such as the ignition switch, nearly all of the desired functionality of the car can be diminished. Dish of food. A dish of food is a unique combination of possible meats, starch, vegetables, fruits, spices, seasonings, proteins, carbohydrates, fats, vitamins, and nutrients, precisely cooked and arranged, that only in its provided organization does the dish provide the nutrition, taste, experience, and convenience that the consumer desires. If just one of the components or processes are spoiled, perhaps too old of meat or being undercooked, could the functionality, notably nutrition, be lost or even harmful to the consumer? Software program. A software program is a unique combination of variables, data types, functions, operators, loops, and routines. Only in its provided organization do all of the components of code work together to provide the functionality the user desires, such as quick responsiveness, lack of freezing or crashing, ease of installation and understanding, convenient interface, and performance of the specific tasks. If just one variable, function, or line of code is out of place when a specific action is requested, it could freeze and become inoperable. House. A house is a unique combination of foundation, support beams, drywall, doors, windows, roofing, plumbing, wiring, heating, and cooling systems, and rooms that, in its provided organization, does it provide the ability to use the bathroom, store and prepare food, relax and sleep comfortably, and use all of our daily appliances. If, say, the supply of water to the house was cut off due to faulty plumbing, the overall usefulness of the house would significantly diminish, where we may not even want to live there at all. Business. A business is a unique combination of assets, including equipment, buildings, instruments, computers, and machinery, all with their unique functionality in concert with a unique combination of labor, including the outputs of engineers, scientists, marketers, admin, finance, technicians, and managers, all with their own unique skills and knowledge over the assets, that when properly organized, produce revenue greater than its expenses. If the components of capital and labor are even slightly disorganized, perhaps in producing a slightly faulty product that has to be ultimately recalled or refunded, the profits of the resulting business could significantly diminish. Human being. A person is a unique combination of molecules, proteins, DNA, cells, neurons, bones, veins, blood, tissue, and organs, such that, in its specific organization, the person can fend off decay and disease, digest food, observe and learn the world, communicate with others, get a job, procreate, and be productive. Just a slightly different arrangement of chemicals or neurons, notably in the brain, could easily lead to severe disorder and possibly death. We can see how the functionality of property is highly contingent upon its internal organization, of which we control as property owners. How can the organization of property create capital? Capital is created through this process of organizing property to provide the functionality we and the market desire. Given the measurement of capital as the most recent market price paid of property, we can calculate if an organization of property creates or destroys capital, if it is profitable or unprofitable. We do this by taking the capital of property and subtracting from it the capital of all the components of property that went into creating it. Let's consider a smartphone. Imagine a smartphone manufacturer who organizes material components, equipment, and labor to create and sell a smartphone. All the material components, such as the microchips, battery, logic board, display, casing, and the like, add up to $200 per phone. The use of labor and licensing to design the software add up to $50 per phone. The use of equipment and factories to manufacture the phone add up to $100 per phone. The use of labor to manufacture the phone adds up to $50 per phone. Total capital used to create the phone, its cost, add up to $400 per phone. The manufacturer then sells the phone for $600. The organization of materials, equipment, and labor to create this phone creates $200 of capital. Now imagine if after purchasing that smartphone, an individual throws it in a powerful blender and blitzes it to create a pile of broken parts and dust. The material components add up to $600. The use of blending equipment adds up to 15 cents. The use of labor to press the button for a couple of minutes adds up to $1. The pile of broken parts and dust sells for $1. The organization of material, equipment, and labor to create this pile of broken parts and dust destroys $600.15 of capital. Effectively, an individual or company knows if they have created or destroyed capital if at the end of organizing their property, they end up with more or less capital than they started with. This change in the capital of property owned is what I will call net income, effectively profit. However, an important aspect to consider when calculating net income is in keeping track of the capital of property over time. When measuring capital over time, the concepts of inflation and deflation must be addressed. In choosing a form of property, e.g. dollars, to be used as a reference to measure the capital of other forms of property, e.g. a house, we must also consider the capital of that reference property, dollars. Just as the capital of a house can change over time due to the supply and use of housing, the capital of dollars can change over time due to the supply and use of money. Going back to the theory I proposed of what capital is, that it is the quantification of property's functionality used by other forms of property, then the capital of a house shouldn't change just due simply to the change in the supply and use of dollars. For calculating the capital over time of any form of property, a price index of a reference form of property is needed to adjust for that reference property's supply and use over time. Price indices like the Consumer Price Index, CPI, attempt to adjust the value of US dollars over time based on the US dollar cost of living over time. Assuming that people's needs for living don't change over time, this can be a fairly reasonable form of adjustment. However, such an assumption is not perfect, since in many ways our expectations of what living means changes over time, such as expected lifetime and typical quality of life. Perhaps the daily and annual needs for expecting to live to 80 years are quite greater than the needs required for expecting to live to only 30 years, such as in previous eras and in underdeveloped areas of the world. Also, the needs of human beings are just one part of the economy. The market includes many other forms of property, all of which with their own needs and uses. However, given these flaws, which I hope to address further in future works, I will be utilizing the CPI to adjust the capital of property over time with respect to their capital measured at previous times. This can be calculated as follows. The capital in the present is equal to the capital in the past times the CPI in the present divided by the CPI in the past. For example, a house purchased at $200,000 in the year 2003 would have an adjusted capital of $266.4 thousand in the year 2017, where the CPI in the present is 245.1 divided by the CPI in the past, which was 184.0, multiply that by $200,000, and you get $266.4 thousand. For an individual who buys such a house for $200,000 in 2003 and then sells it for $266.4 thousand in 2017, they would derive zero net income from such transactions since the capital of the house has not changed. Only the capital of dollars has changed. So from here, we can understand how capital can be created or destroyed based on how we manage and organize property. It is from this very organization that creates or destroys capital. The components of property alone are not enough to define the capital of property. The components must be properly organized as well. As seen in the smartphone examples, just by rearranging the components of the smartphone to either a functional form of property or a non-functional form of property, we can drastically affect its capital. The capital of property is contingent upon its organization. This productive organization of property is the principal difference between the book value of property, the sum of prices of the components, and the market value of property, the price of the property on the whole. This is true of companies and true of all forms of property. Property rights establish for the property owner the exclusive right to organize their property as they see fit, to create the functionality they most desire to produce. The production of capital would posit to organize property into those functional arrangements that increase its functionality to the market, increasing its capital. However, the functionality and capital of property is not just determined by its internal organization, but also its external organization, which includes the environment, the marketplace, and the enforced laws. What good is a smartphone without a signal? What good is a car without roads to drive on? What good is petroleum without a refinery? What good is land if it is illegal to build or live on it? What good is platinum if it is on a distant asteroid? What good is a house without utilities like clean water, electricity, and internet? What good is property if it is to be forcibly seized by criminals or organizations, if it is not secure? To this extent, too, where we have knowledge and power over the environment of property, we can change it to alter the functionality of property, changing its capital. However, property rights cannot entitle a property owner the exclusive right to change the environment affecting their property if in doing so, they negatively affect the capital of other property owners. This principle of power over the external organization of property is to be discussed in the later chapter, A Political Structure of Capital. For these purposes, political rights are required as an extension of property rights. The production of capital would posit to use these political rights to best create an environment, marketplace, and set of laws that increase the functionality of property, increasing its capital. To conclude, I argue the following basis of capital: that it derives from the functionality of property that is used by other forms of property. that the functionality of property is derived from its nature, of which we can understand through knowing theories of nature proved logically and experimentally. This nature includes property's organization, internal and external. To the extent we have knowledge of nature and power over property's organization, either individually via property rights or collectively via political rights, we can change the material world to create or destroy capital.